so this is going to be a short video. Most of the stuff for carrying out a significance test for means is largely the same as it was for proportions, with just some minor tweaks, obviously, because we're dealing with means. And we're going to use the t-distribution rather than the normal distribution. All right, so the first thing you're going to need to do, just like before, you're going to need to check to make sure the conditions are met. Now, just like with confidence intervals, the proportions for a significance test are as follows. First, make sure it's from a random sample or a well-designed experiment. That's almost always going to be the case. Very rarely do they give you questions in which it's not the case. Is the sample less than or equal to 10% of the overall population? You want to make sure that your sample size isn't more than 1/10 of the whole population. Now, this is important because a lot of people in proportions were getting the sample size mixed up with the number of successes in a sample. Obviously, in a sample for proportions, you can have more than 10% of the sample be a success. Thankfully, for means, we don't have that sort of scenario. We don't have that comparison. It's literally just, is the sample less than or equal to 10% of the population, yes or no? Next, is the sample size 30 or more? So if the sample size is 30 or more, then you can go ahead and proceed with the significance tests. If you know that the population distribution is normal, you can also go ahead and proceed with significance tests. If to either one of these questions the answer is no, then what you're going to need to do is make a dot plot of the data, and if the median is pretty close to the mean, then you know that it's not going to be skewed very significantly in any situation, and as long as there's no ridiculous outliers, you should be good to go. Basically, if you can say yes to all three of these, with this being the caveat if number 3 isn't set, if you can say yes to these, then you're good to go, and you can perform significance tests. Now again, the significance test of choice for this unit is going to be the one-sample t-test, similar to a one-sample t-interval. The reason for this, just as before, is you are usually not going to know anything about the population standard deviation. It's not something that's normally given to us. Of course, if your sample size is 30 or more, and you know the population standard deviation, you can do a z-test, which is largely the same as this, except you sub in sigma instead of s, and you sub in z instead of t. But usually we're going to be doing a t-test, and the procedure is as follows. First, you find the critical t value for your sample mean. So you take your sample mean minus your supposed population mean divided by your sample's standard deviation over the square root of your sample size, and that gives you your t-score, if you will. Then, depending on your critical t and your degrees of freedom, you find the p-value from the t-table that is most closely associated with that critical t or that t-score. If the p-value is less than whatever you set your alpha, whatever you set your significance level, then you can reject the null hypothesis. And if not, then you fail to reject, just like before. Of course, you can also use the calculator to find the p-value, and you do not need to go through the process of doing this by hand, and you can avoid the t-table altogether. I'll show examples of both how to do this by hand and using the calculator in this playlist. Things that you should probably remember, because most of you probably forgot. Remember, your null hypothesis is always going to be that your statistic in question, which in this case is the population mean, equals some number. Just like before, it was always your proportion equals a number. Now it's the mean equals some number, and it's always about the population. Your alternative hypothesis is that that same population mean is either going to be more, less, or just different from whatever you set your null hypothesis to. When we perform the test, we are assuming that the null hypothesis is true, and therefore when we get our p-value and we compare it to our significance level, we'll either reject the null hypothesis, suggesting we have evidence to support whatever the alternative was, or we fail to reject the null hypothesis, meaning we don't have enough evidence to support whatever the alternative was. Make sure when you're answering this in a free response setting, you state the significance level, you state the alpha before you actually do the test. You can't go back and say, oh, well, it's this level. No, just say what it is beforehand. It's usually 0.05, just like before, if it's not given otherwise. Rejecting the null hypothesis is based on whether or not your p-value is less than alpha. If it's less, then you reject. If it's not, then you don't. A lot of you got your sample proportion mixed up with the p-value in the last unit for some reason. I don't know why. I guess the same letters are confusing for some. Whatever. Thankfully, you don't have that problem this time because we're dealing with X bar instead of a P with a hat. And that's all we have. Like I said, I'll link some examples of how to do this both by hand and using the calculator later on in this playlist. In the meantime, I hope this was helpful.